All right. Welcome, everybody. We are recording this screencast in front of a live audience at the Floe offices. So if you hear some background coffee shop noises, that's just our kitchens. Our presentation today is titled Lean Software Development for Drupal Projects. This is the 2016 edition of this talk, which I gave at the Drupal North conference in Montreal 2 weeks ago. This year's talk is a new iteration on a talk I gave on the same subject at Drupal North Toronto last year. And since I got some good feedback and people were very interested, we thought we should share this with the broader Drupal community. So does this describe you? You've worked on at least one web development project that missed its schedule. Maybe you've worked on a project that spun out of control and no one knew what to do about it except work harder. Maybe you've worked on a project that completely fell apart and nearly destroyed the company in the process. I hope that last one was just me, but I see at least one raised a hand in the audience. And let's never go through that again. What I want to share with you today is what I learned about controlling projects and other software development work through hard, painful experience. I'm not going to sell you Scrum or Agile or Kanban. I think other people have already done that. I'm going to describe why it happens that Scrum, Agile, and Kanban work, and within what conditions, and then give you the tools to feel in control of your work, even if you are a team of one. These tools all revolve around achieving control over a single concept, that of your inventory of work in process. I'll begin by explaining how work in process affects our projects, followed by the most common techniques that allow us to get control over work in process. Finally, I'll explain the relationship between work in process controls and agile tools. Hopefully, by the end, you'll have noticed ways that you can improve your projects with very little effort and without applying heavy team management frameworks. But first, a word from our sponsor. I work for Floe Design Technologies here in Montreal. We're specialized in medium-scale Drupal sites for multilingual organizations, and we take care of the whole life cycle of web software, from early UX design to long-term operations. You can learn more about us at floe.ca. This is our whole company. Half of us are on the production side of things, the other half is management and support. Since we're a small team and we provide whole lifecycle services to our clients, we have to deal with many dimensions of project and software management at pretty random times. That's me down there. My name is Mathieu Ely, and I'm a senior developer at Floe. I joined Floe last year after a career being a solo developer, first as a freelancer, then as a contractor, then by founding a heroic startup with video production partners. Besides being a Top Gun software developer, I also studied economics, and I've been fascinated by the economics of software projects and how much friction they create in the software production process. Through all this, I learned the hard way that delivering software projects is chaotic. Then I learned to stop worrying and enjoy lean software development. Let's start with some backstory. Lean production methodology was invented at Toyota under the name Toyota Production System. That's Mr. Toyota, who founded Toyota Motors. You see, the people at Toyota had a big challenge. They were working in post-war Japan, which was very poor, and could hardly compete with the big American automakers with their big cars and their enormous economies of scale due to mass production. But they were very pragmatic people. They took a very introspective approach to improving their production, and they noticed 7 areas where the company was being wasteful, and that the American automakers were not paying much attention to. Those were the 7 wastes of manufacturing. After paying close attention to how production was being handled, and how all this related to the market demand for their cars, the leading engineers at Toyota figured out where there was still wasted effort. I'm quoting this from Wikipedia's page on lean manufacturing. It was transport, moving products that are not actually required to perform the processing. Inventory, all components, work in process, and finished product not being processed. Motion, people or equipment moving or walking more than is required to perform the processing. Waiting, for the next production step, interruptions of production during shift change. Overproduction, that is production ahead of demand for the product. Overprocessing resulting from poor tool or product design creating activity, and defects, the effort involved in inspecting for and fixing defects. The solution to all these came to be known as the Toyota production system. The engineers realized those wastes resulted from assumptions around efficiency. Americans loved efficiency. They wanted their factories and machines and workers to be busy all the time because they were paying for them and they were trying to lower unit costs. What they didn't realize was what it cost for the work in process inventory that was waiting to go through these efficient producers. Toyota expanded the cost calculations to account for the cost of having a lot of work in process. By careful observation and reconsidering how factories were supposed to operate, they created a whole new kind of industrial production system. Their solution was called Kanban, which involves making a stage of a factory stop working if too many parts or too many cars accumulated in the next stage of the factory, either because they were making too many or because something had gone wrong somewhere down the line. This limited how much it cost the company to hold this work in process inventory and reduce the 7 wastes. They then spent decades figuring out how production could run with even smaller work in process inventories. And they kept slashing costs down and improving quality until the American and European companies had to adopt their model. Eventually, this model became externalized to suppliers as just-in-time supply chains, where the inventory was held on trucks driving to their factory that would arrive right at the moment the factory needed it. So that's enough of Toyota. What about lean software development? That was the title of a book written by Mary and Tom Popindick to demonstrate how the 7 wastes identified at Toyota also show up during software development, but under other names. Their list of wastes was partially done work, extra features, relearning, handoffs, delays, task switching, and defects. So it's an interesting observation that manufacturing waste has corresponding types of waste in software development. But in software, we don't really have a factory floor with partially assembled cars moving through it. So what is it about software production that has features in common with industrial production? The common problem is queues. On the left here, we see a queue of people waiting to use the restrooms at a software conference. And on the right is the issue queue for the core of Drupal. These are pictures of the same problem. We have a service process interacting with a demand process that is too big or too variable for it. It turns out the trade-offs between efficiency and work and process costs is pretty universal. This bathroom line is wasteful the same way that this issue queue is wasteful, the same way that the Toyota production line was wasteful before they went lean. But it's worth noting that the bathroom is being very efficiently utilized. Where else does work inventory show up? It can also be purely mental. Anyone heard of getting things done, the revolutionary life management process? Some people. The idea is that we hold so much of our to-do inventory in our heads that it drives us crazy and prevents us from actually doing those things. Our brains are completely utilized just at remembering all the things we have to do, and has no power left to actually do them. David Allen proposes to write it down, and then work on organizing the list into their proper context, where context-switching economies can be realized and the overhead of reading your to-do list diminished. If you're not doing this with your software work, by the way, and you try to keep it all in your head, your work is probably out of control. So software inventory takes many forms, and not all of them code. What are their source? Joel Spolsky, who is the co-founder of Stack Overflow and a famous blogger, launched Trello a few years ago with a meta blog post about how software inventories affect projects. He identified many sources of queues and work in process inventories. Here's a relevant quote from his blog. Think of product ideas as the raw material. Depending on your process, product ideas may go through several assembly line points before they are delivered as finished features to the customer. First, a decision-making process. Should we implement this feature? Then a design process. Specs, whiteboards, mock-ups. Then an implementation process, writing the code. After that, a testing process, finding bugs. A debugging process, fixing those bugs. And ultimately, a deployment process, sending code to customers, putting it on a web server, etc. In between each of these stages, inventory can pile up. For example, when a programmer finishes implementing their code at stage 3, they give it to a tester to check at stage 4. At any given time, there's a certain amount of code waiting to be tested. That code is inventory. End of the quote. He concludes the blog by stating that Trello is designed to be intentionally hard to use when too many cards pile up, nudging you in the direction of limiting that inventory. If you don't have any work inventory tracker right now, Trello is a great and easy place to start. So in that sense, software development processes form what are called linked queues. That means that the rate at which work arrives in one process is determined by the rate that it gets finished by the last process. The more processes we have in a project, the more opportunities for long queues to form. And the more we have to pay attention to the impact of these queues. And in Drupal development and web development in general, we have the creative and editorial process that adds even more queues. It gets so hard to picture that some web designers make graphics like this one to explain to their clients what journey they're on. But even this can be deceptively seductive because it does not show how the scale of the project impacts the cost of these queues. So what are those possible impacts? Let's go through some of the most common. Big inventories hide defects. When you let a big inventory pile up before moving the work to the next stage, you allow defects to remain hidden for a long time. This means that the defect is likely to be repeated and multiplied in other tasks. For example, your designers might produce a mock-up that requires breaking the laws of physics. Unless this work goes to the front-end developers quickly, the designers will keep designing more mock-ups that break the laws of physics. And I don't want to single out designers. Developers produce defects too. Let's say that a developer introduces a configuration that is incompatible with the production server. Until this code goes to integration, we have no idea that it is defective. So the developer will repeat the defect multiple times, and it will require multiple bug fixes at the end of the project, where we are most sensitive to the timeline. Big inventories generate overhead. Overhead is all the work that's performed just to manage the inventory itself. Imagine we have an issue tracker with 10,000 issues. If we find a new bug, we have to go through all 10,000 issues to make sure it's not a duplicate. Or we just create a duplicate, and now we've added wasted effort. If we close bugs quickly, bug reporting goes more smoothly. The same is true of a meeting to monitor the progress of tasks. If we have a meeting to discuss 10 tasks, we can go into more details than a meeting to discuss 100 tasks, which will probably turn into abstractions and last so long that people will complain about bathroom breaks. Big inventories have interactions that create bigger inventories, and Drupal 8 provides a great example of what not to do. The development process for Drupal 8 took about 5 years, and by some measures is still ongoing. The Drupal project itself is only about 15 years old, during which it went through 7 versions, so things have gotten worse over time. The problem is that we had so many initiatives for Drupal 8. We wanted to make Drupal responsive. We wanted better configuration management. We wanted to refactor the core on Symfony. We wanted Twig templates. We wanted web services. And once it was decided that they would all be in Drupal 8, we couldn't declare it finished until all the initiatives were all finished. The release of Drupal 8 was held back by its slowest and most complex initiative. It doesn't matter which one it was. It could have been a different one at any particular time. We could have just shipped a responsive Drupal or just a Symfony core first, and not had to wrangle all those initiatives with the other ones and the bugs they introduced. Drupal 8 would already be everywhere and competing with other frameworks. The good news is we have learned that lesson, and we now develop new features on minor releases of Drupal 8 instead of waiting for Drupal 9 to have them. So Drupal 9 might take 10 years, but Drupal 8 will continue to improve in small increments. Big inventories are perishable. Common sense tells us that selling 10,000 bananas is going to be more wasteful than selling 100 bananas 100 times. That's because bananas are perishable. They are sensitive to waiting. Our work is also sensitive to waiting. A design mock-up from 5 years ago is likely to be out of fashion, if not plain obsolete. Code from 5 years ago might not be supported by today's production servers. And most important of all, market conditions may suddenly change, and our users' requirements may change along with them. They aren't just changing their minds, they are adapting to a new situation. Work that has waited too long to be finished may suddenly become useless, and all effort in it go to waste. Big inventories hide risks. I was once a contractor on a project that required an organization to change their business process substantially. And when we delivered the software under that assumption, they realized just how big an investment they would have to make internally in order to use it. So the project costs suddenly exploded for them, and the project was likely canceled a short time after I left. Had we done early and frequent integration tests into their organization, this waste would have been identified and the project terminated or changed while everyone was still good friends. It would have cost some money to discover that the project was doomed, but the cost of obtaining that information would have been minimized, and maybe some other project would have been launched in its place. Big inventories delay value. Even assuming that we have no problem with defects or overhead or risks, big inventories are costly on their own. They represent an investment that's not yet producing any value. Our clients value software and production. Anything else is just an abstraction to them. And the more work you have invested in your inventory without shipping any software, the more costly it is. The less work remains to be done on an item of inventory, the greater the opportunity cost of not shipping it. The more work items you have waiting, the more the total cost of waiting. One item waiting 10 weeks is cheaper than 10 items waiting 2 weeks. The fact is that long queues tend to stay long for a long time. So the interaction between those costs means that we have to think of it kind of like the Richter scale. It's not just the amount of work waiting, but multiplied by how long it's been waiting. So now that we went over why queues are the cause of all our pains, let's look at what solutions are available to us to make them less damaging. The most powerful technique is called batch size reduction, which in its extreme form is called one-piece flow. It's been proven that working on a single item at a time is more effective overall than doing large batches of many items at once. If you don't believe me, watch this video called Lean Manufacturing One-Piece Flow Simulation on YouTube. Let's start the video. Where to prove it to you, a guy spends 10 minutes filling envelopes by first doing one task at a time, then by doing one piece at a time and comparing the results. Let me get some water while you watch this great video. So the problem with one-piece flow for us in software development is that we don't really have discrete work pieces like letters or cars. What we have instead are value items, features or behaviors that our customers think would improve their lives. What we can often do is break these down into separate work in process tickets, as long as they don't have dependencies on one another. And if we can finish one and deliver it to production without finishing the others, there's very little reason not to do so. The lives of our users will be improved sooner rather than later, and we will find and prevent more defects. You can click the link below on the slides, or I'll put the link on the YouTube video of this presentation. Automation. One of the biggest reasons people mention for working with large batches is the overhead of running a batch. Releasing just a small feature is not a good idea if you have to test the whole site just to make sure that small feature did not break an existing, much more important feature. This is why one of the most successful changes in practical software development of the past decade has been the introduction of automated tests and its ultimate realization, continuous integration. Since a single batch of automated testing costs almost nothing, we can test very small changes for regressions and get instant feedback from our changes. And we can fix bugs while the code is still fresh in our minds, another example of perishability. I strongly recommend you start your next project with a testing framework, something that preferably makes writing tests easy. Because testing is a task that tends to grow as the scope of the completed work in the project expands. As an intermediate step, just write down the tests in text files in your project's documentation so they can be converted to code when it becomes too painful to run them manually. Here's good news. Unlike manufacturing, where every part waiting on the line is usually identical, and all you can really do when a big queue of them forms is stop adding more, in software, our work items tend to be wildly different. This creates opportunities for prioritizing one item over another, and to reduce the cost of large queues when they arise or when they are inevitable. That technique is called queuing discipline. The three most relevant ways to sequence software work are highest cost first, then riskiest task first, and finally fastest task first. Let's look at some illustrations of those. Highest cost first. This one is kind of common sense. If we have 10 work items, we ask our client to sort them in the order that they think is worth more to them, then work from top to bottom. That means that waiting costs will shrink the fastest. This is the kind of queuing discipline practiced, for example, in emergency rooms. Someone who comes in with a critical injury gets treatment before someone with the flu. The term they use for this is triage, I believe. Riskiest task first. This is the approach behind the lean startup methodology. The idea is that our queue is full of tasks that only have a probability of being successful, and other tasks that are accessories to them. If we test the riskiest task first, and they fail, we can avoid working on all the accessories and save our efforts to make a different attempt at solving the problem. Once we've found a stable solution, we can resume the highest cost discipline, assuming we didn't purge all our work because it doesn't make sense with the new solution. Let's talk a little more about what a lean startup is. For those who don't know, Lean Startup is a book that transformed the world of tech startups by introducing them to lean methodology at the point where business and technology converge. It's where terms like minimal viable product and business model pivot come from. In it, author Eric Ries shared this story. He was launching a company which wanted to connect teenagers using instant messaging avatars, seen on this slide. Because teenagers, of course, love these sorts of things. To use the service, they had to download a plugin to share their friends list. This would feed the company's viral growth model. What he eventually found out was that no teenager wanted to take the risk to look uncool to their friends. But what they did want was to make new friends. And they didn't mind installing a whole new messaging app instead of using plugins. So the whole plugin was thrown out and development started over. The Lean Startup is about this conclusion. Only build a minimal viable product to test if people actually want what you have to offer them. It took a whole product iteration for them to learn this. And they observed in their retrospective that they could have done it much cheaper and faster with a barely functioning prototype instead of a polished product. Fastest task first. So if everything has the same value and presents the same risks, there is still a way to practice queuing discipline by shrinking the overhead of the queue itself. You just finish the item that is quicker to finish first and make the queue shorter. Imagine an unsorted pair of clean socks coming out of the dryer. How do you pick which pair to fold? You pick the first one you can see. Then your pile becomes less ambiguous, and you can find another pair. You're not wasting time looking around for any specific matching sock. This also works if you have a sink full of dirty dishes. Don't clean the biggest, heaviest item first, because you will have to move everything around to do it. Clean the cleanest thing and put it away, then the next. When you finally get to your big dirty pot, you will have a lot of space to manipulate it, which you wouldn't have if you tried to clean it first. And if you want to be super lean about it, don't even put dishes in the sink. Clean them as you use them and put them back in the cupboards where they are ready to produce value again. These last two techniques are a good way to resolve the ambiguity in a large project. Drupal, since it relies on assembling a lot of large contributed modules, tends to create projects with a lot of ambiguity. Where do we start is a frequent question when faced with a large batch of work. So finishing small parts can give you more insights into the whole and motivate you to keep going until you can reach the big chunks with a clear picture of what you're going to do. It also lets you test your release process sooner and get feedback from your users sooner, so you can start a new iteration of the project sooner. I've mentioned the word iteration at least twice, so I think it's time we covered this topic. So let's move on to the popular topic of agile software development, which relies on rapid iteration and learning. Iteration means doing some activity using its own output as an input, starting from the result of a previous iteration. It means a feedback loop. So each iteration, we get a small improvement over the last one. Iterative development benefits immensely from batch size reduction, but it doesn't mean the same thing. Let's look at an example. Imagine that we are painting a house. We have a crew of roommates who are not professional painters. We bought some stuff at Home Depot and picked some colors from a magazine. We have many risks here. We have unknown labor skills, we have unknown equipment, and we don't know how much work is involved in painting the whole house, or if we have enough paint. And we don't know if our colors will turn out any good. If we try to paint the whole house in one batch, we risk having to start over at the end, or wasting our time with ineffective rollers, or ending up with bad colors. We might have to start over the whole house, which would be a huge iteration. If instead we just painted one room, then observe the results, we can do a team retrospective and see what changes need to be made before we start the next room. We can even repaint that one room in a new iteration if it didn't come out as nice as we wanted. This is agility. We have the opportunity to change to adapt to the project. The key to improving our agility was to shrink the length of our iteration by reducing its batch size and sequencing future batches after deciding whether to run another iteration of that room. So the key to software development agility is going through whole project iterations very quickly instead of just once. We can be redoing our requirements each time we deliver new working software to production and always get the freshest requirements. And of course, if we're only taking on a small batch of requirements each time, we don't need to build up as large a backlog in the first place. So, ambiguity is not being sure about what you're looking at. But in contrast, uncertainty means knowing what you're looking at, but not knowing what to do about it. We have a lot of uncertainty in software development, and even more so in web development. And the way we manage that uncertainty is by hiring designers. A designer is someone who starts with just an idea that someone wrote down on a napkin, then explores as many different possibilities of outcomes for this idea. The way to do that is to create the most abstract simulation of the outcome, which is what's called a model. Just like we don't want to build an entire city just to find out if the lighting pattern will be good, when we can just make some small wood blocks to get the same information. We don't want to build a complete website before we figure out whether or not its features will be valuable. So for example, if we don't know what colors would work on a website, we can make just some style tiles and see how different graphic elements harmonize with each other. If that doesn't come out nicely, we try different colors and patterns. This is obviously a much faster way to go through an iteration than it would be to build and release a full website. You just build and test a small model of the feature you want to test. If your test passes, you deliver that model as work inventory. If the test fails, you build another model, and you save your team a lot of wasteful work. This has the advantage of being a very small batch of work compared to fully realized software, so we can go through the loop many times and improve very quickly. So, we have modeling tools for all sorts of features of websites, for graphic design, for user interface elements, for interactivity. And a new trend is to build a high-definition model of the website as fully realized HTML and CSS templates before we plug in a web application, using systems like Pattern Lab and Atomic Design. That way, designers and front-end developers can go through many iterations of their work before the back-end developers are ready to release the full application. But one misunderstanding that causes a lot of friction between designers and developers is that the model can only be a test of a feature among many other tests. It doesn't guarantee that the feature has value. And in the end, if the feature cannot be translated to working software, that feature has failed the next test. So it's important to test models early and often with the clients or users, but also not to let the models wait before developers can evaluate them for defects that prevent software being made from them. Another aspect of projects that people struggle with are estimates. But clients need them, as well as account managers and other kinds of people who depend on the software's release to plan their activities. They're also essential to practicing some forms of queuing discipline, such as shortest task first or riskiest task first. So how can we make estimating painless? First, we need to know what kind of decisions are to be made with these estimates. If all we want to do is report the progress made to our client, we can show them the ratio of tasks completed over time. This is the principle of a progress bar. It's much less stressful to know that progress is being made, even if it is being made at a highly variable rate. Not knowing the rate of progress during a wait can be so stressful that progress bars nowadays are designed to look like they're moving, even when they're perfectly still. Like, notice the candy striping on Drupal's progress bars? We know that when we look at a progress bar, that the time remaining the computer is showing us is only an estimate. But the point is, the potential error of that estimate is tolerable. We can make the progress bar more precise by giving weights to our work items. That means evaluating one task as having, say, 5 times more work in it than another task. This is the agile technique of story points. And it's an easy way to continuously estimate how much work remains in a project. It's also more honest and more reliable, since it allows you to measure time remaining by time elapsed, instead of relying on people's typically biased time estimates. If you practice shortest work item queuing discipline, your progress bar will make progress quickly at first, then start slowing down. So having estimated the weight of remaining work will prevent your client's stress levels from increasing at the end of the project. The most advanced type of progress bar, and the one most widely used by lean organizations, is the cumulative flow diagram. You display over time the evolution of the progress bar for your project. So you can see not only how much progress has been done, but how much longer the progress bar gets over time. Because of course, work keeps being added to the project. On a cumulative flow diagram, the vertical lines represent a progress bar at that moment in time. Interestingly, by looking at the horizontal lines, we can describe how much average time is spent waiting for and processing work. Let's talk about Kanban again. Earlier, I mentioned how Toyota changed manufacturing by a technique called Kanban. I'm going to explain in greater details what this is, because Kanban is also used by many agile software teams. The idea of a Kanban is to create a limited space for providing work in process inventory. At Toyota, they use tokens. In some factories, they can use pallets. Software teams often use post-it notes. As long as there is space made available by a process, you can produce and provide more inventory for that process. When the space fills up, you should stop work until it's available again. This has the benefit of immediately telling you there's a bottleneck in your production and calling for the intervention of outside resources. This is called a leading indicator, as opposed to a lagging indicator, which tells you there's a problem only after it has happened, like when a project has blown past its deadline. Kanban is harder to practice if you use a software tracker, since typically there's a limitless space in the software. You can use a system like Trello that makes space explicit as cards, or more complex software like Jira that allows you to define work in process constraints. Scrum. Scrum is a very popular agile framework for teams. Unlike Kanban, it doesn't have the concept of limiting work in process explicitly, but it achieves the same result through the use of time boxing. The team only starts the amount of work that can be delivered and shipped in the length of one sprint. The team only works on requirements definition that can take place in one meeting. And the team only discusses problems that fit in one retrospective meeting. Scrum's most interesting feature is its use of cadence. Cadence means making processes take place at regular time intervals. It can mean releasing software at the same time each month, for instance. It can also mean having a short team meeting, the Scrum, at a specific time each day. This may be the opposite of what I've been saying this entire talk, but cadencing daily meetings works because it creates a single batch of team communication instead of having team members interrupting or waiting for one another all day long. This eliminates context switching and gives developers more and longer focused work time. It also eliminates the overhead associated with organizing meetings that fit in everyone's schedule. The meeting dates are all set in advance for the lifetime of the project. You don't have to pick one or the other. These processes can easily be hybridized. Scrumban, for instance, uses the cadence of Scrum but with the explicit work in process constraints of Kanban. The meetings are used to refill the inventories. Scrum is a popular and very successful process, but it tends to break down outside the context it was created for, which is teams building software within organizations. It doesn't really have any place for modeling, for one thing, and it doesn't prescribe how to manage client-vendor relationships. That's considered a problem for management outside the team. For many of us, though, there's no distinction between management and team. In some agency settings, it's very easy to get derailed by sudden emergencies or opportunities. Then the cadence of the team is broken. Or sometimes you just need to work on disparate projects at the same time, and having a sprint planning meeting with all your clients doesn't make sense. So what I suggest you do is take a look at these techniques using Lean as a language. Then figure out what works for you and when it works for you. Adapt the frameworks as you need. Be agile with your process. This is a screenshot of our operations board. I told you at the beginning that we do full lifecycle operations for our clients, so that creates a lot of variability in our demand streams. We created this board to manage all those operations simultaneously. Before we switch to this system, we would typically wait for a bunch of code to be done before deciding to do a release. Then we would spend between days and weeks trying to coordinate the different release activities with the team QA process, the customer's QA, the developers fixing defects found in QA, and finally the sysadmins pushing the code to production. The problem was that no one who created an issue or developed software had any idea when that work would be finished, or how long it would have to wait because of unrelated problems. So let's see how this new board resolves this challenge. Let's go through the board's columns from the right, where software is fully completed, to the left, where customer value is being defined. The most important part here is the release column. We do scheduled releases, which means whatever work has been completed at a given date gets released, and everything else waits for the next window. This requires all of our work in process to be in independent branches in Git, which is why we have a ready-to-merge inventory. Before we declare something ready, we always have a team member that did not develop a feature do a review of it, to ensure that it makes sense and works on other environments, and that other people can maintain it. We have soft work in process limits. The red column for review tells us that we need to focus on that before starting more work because it has gone over the limit. And we don't want to miss the release window with software that's almost finished. On the left side, tasks that are identified by developers can instantly start in the ready for dev inventory, usually bug fixes and upgrades. Tasks that come from managers go into needs evaluation, so the developers can determine if they can work on it or what needs to be changed. Tasks that clients identify go into selected. We've been working like this for a few months, and we're constantly revising our process. It might be different next month. We don't know what's coming at us, really. Being agile in your process, as well as your project, is the ultimate form of agility, as long as you know why the change you're making is optimal for you at that moment. Okay, let's wrap this up. What I want you to remember from this talk is that it is much more important to keep track of how much work you have in process than how long it is taking to finish it. The reasons for that is that having large work in process inventories make projects spin out of control and miss their deadlines. And if you just track timelines, you can only react when it's too late. And finally, I wanted to show how agile methodologies use these principles and how you can use them to develop your own work process that reflect the kind of products you make for the people who need them, instead of dogmatically applying the existing frameworks. Thanks for staying along the whole way. And one more thing. If you'd like to know more beyond the obvious literature on lean software development, I highly recommend the Principles of Product Development Flow by Donald Reinertsen. It's full of geeky formulas and statistical proofs that show why these principles work. The Lean Startup by Eric Ries is also a very eye-opening story, even if you have no intention of ever founding a startup. And if you haven't read Getting Things Done already, put that on your to-do list right now. Okay, so when I did the talk at Drupal North, I had a few questions at the end that were highly relevant. Someone asked, for what kind of project this would work best? The answer is that the principles are universal, but the effect gets more powerful as the project gets bigger and with more intermediate steps between someone expressing a demand and working software being delivered to them. This is why waterfall development got a bad reputation. Waterfall is the assumption that you should wait until all work at a step is finished before starting the next step. And obviously, that triggered all the impacts of large inventories when projects became very large. On the other hand, if you follow a non-iterative process like the one with the bubbles shown earlier, This can be a perfectly valid way to work if you do it very often and take advantage of what you learn each time to start a new project. So a company that launches a website every month would be practicing iteration on its set of projects, even though a single client will not be aware of the Agile process and would not need to be aware at all. The next question was how this would work for distributed teams. Distributed teams don't have the advantage in communication of being co-located, so having reliable communication channels is very important. But even more important is to make the inventory of work visible. This is the most fundamental thing about Kanban, for instance. Your team should be able to have daily meetings around a collaborative board and go through the latest changes to the work inventory to make sure the information on the board reflects the real status of the work. This is something Trello is very good at. Jira doesn't have as good real-time collaboration support. And by the way, this is good advice for co-located teams as well. Someone asked, where do we expect to be in our process next year? The answer is there's no way to know, because we really don't know what kind of work we will be asked to do next. There's not as many organizations asking for whole new website redesigns, but many will probably want to migrate to Drupal 8, and this implies a different approach to project management. Or maybe we'll do pattern libraries instead of full CMS applications. Or maybe rescue a full CMS application that a different company worked on. And we're there to help our clients solve an urgent problem they have. So we have to adapt our work processes to those problems. This brings me to the last question. How do you convince clients to be agile? My opinion is that the customer is always right and you probably shouldn't. If we start imposing a workflow on our customers, what we're really doing is segmenting out of our business all customers that don't fit our workflow. People have their own organizational politics and dynamics to manage, and the reason they ask vendors like us to work for them is that they need a solution to that problem. So agility for them might mean controlling risks, which requires a lot of planning and testing. But for another customer, maybe a multi-million-dollar tech company, it might mean seizing opportunities by adapting quickly to how the marketing department is feeling the market. So you should help your customer by adapting to their process, staying aware of how that will impact the work. And if you're lucky enough to improve the relationship over time, you should iterate with them on it. I can take questions from the audience if someone has one. Oh, thumbs up from everybody. Okay, well, that's the end. Please look us up at floe.ca if you have any other questions. Signing out.